Greetings. As we discussed in our last session, this is what happened. Actually, the upward forces of tires support the vehicle weight. Actually, these upward forces will pull the downward part. Right? Okay. This is just static conditions. They just draw in static conditions. This is what actually happens when it comes to rolling. I mean, dynamic conditions. Just imagine that. In dynamic conditions, this is what is going to happen. The upward forces will pull the downward part of the tire. Right? Okay. So the total will be load. The total load will be supported by the side walls of the tires. These side walls support the total load actually acting on the wheel. As we discussed in our classroom, we just marked 3 points of the tire which is contact with this road surface. Already we have discussed the contact surface separated into 5 points. Now we just get into the 3 points. At first, this is the forward vehicle velocity. Okay, so this is the first point at which the tire is going to hit the road surfaces. This is the second point. The total load will going to take place. So this at this point, the radius of the tire will be RL. This is the third point. It gonna break. Actually, the bond will be break from road surface at this point. So this is the entry point. This is one exit point. This is center point. 3 points we can separate: entry, exit, center. Right? Okay. As we discussed in our classroom, we have seen the tire and road surfaces in microscopic and macroscopic scale, and the pressure developed inside the tire is not going to be symmetric because it has to maintain the equilibrium condition with tractive force in longitudinal direction and vehicle weight, I mean vertical load in vertical direction. So the reactional force given by the ground surface must be in slanting. Okay. So the tire pressure will be varied. This unsymmetric distribution is because of viscoelastic nature. I repeat, this unsymmetric distribution is because of the viscoelastic nature of the tire material. Because we are using elastomers here, elastomers has hysteresis losses because of a basic nature, right? So that is why it is called as viscoelastic material, right? Okay. So I hope you can remember the hysteresis losses stress strain curve which we have discussed in our classrooms, right? Okay. Because of this unsymmetrical pressure distribution takes place, right? Okay. So unsymmetrical distribution of pressure will be takes place at these points. So at the entry point at which the tire is going to hit the ground, right? At this point, the pressure will be maximum compared to these 2 points, right? So I draw the graph here, right? This is our pressure in vertical direction, right? So at this point, the pressure will be maximum compared to these 2 points, right? So maybe here, so we get maybe the pressure distribution like this, right? Right. So at this point, the force, the pressure maximum at this point of entry, right? I just write it here, right? Okay. For further discussion about this one, we go for some other concept, right? Okay. Wait for a moment. I just took a tire ground surface. It is a carcasses for easy understanding, I just draw the carcasses, right? Okay. We can discuss this into two extreme conditions. First one braking condition, another one acceleration condition, right? So let us consider, instead of vehicle moving in this direction, we just consider the road is moving in this direction, right? As we discussed earlier, right? Okay. So the tire maybe rolls like this, right? Okay. So first extreme condition, let us take a braking condition, right? So at first the carcass stick with ground surface, right? So the at the carcass we can say two different points, the point joined with road surface and the point joined with the tire surface, right? These points stick with road surface and this point stick with tire surface permanently, right? Okay. When we apply the brakes, the vehicle does not come to the zeroth position immediately, right? Okay. When we apply the brakes, the tire roll will be locked, the vehicle moves actually, okay, the vehicle moves in this direction but the tire will be locked, right? So this point, what happened at this point? So actually what happened at this point is, it is going to stick with this one, this point is going to stick with this one. When we apply the brakes, this is not gonna loose and this is not too, right? It is going to take a shear here, right? So the shearing will be take here. I hope you can understand what I can say, right? Okay. So when we apply the brakes, when we actually, the road is moving in this direction, tire rolling, right? So when we apply the brakes, what happens, the tire will be stopped, actually locked, there is no rolling, right? The vehicle moves like this, okay. So this point will get shear. And when another one extreme condition is acceleration. So the tire, so the road will be like this. When we apply the acceleration, this is actually happen in opposite direction. So the scrub will be takes place in this direction, right? Okay. Again we come to this one. So actually what happens here, uh, in previous session we have concluded that here velocity will be maximum than higher than this one, here the velocity will be higher than this one, right? Okay. So at this point, it may be braking force or tractional force, whatever it may be. At this point the force will be maximum, right? This point the force will be maximum and come again to zeroth, and again it, here the velocity will be higher than this one compared to second point, third point get maximum velocity, right? So in negative direction, because this one gonna get a positive and this one is negative, right? Okay. So in negative direction we got longitudinal force, right? So two extreme conditions, point number one and point number two. So this is a first region, this is a first point, second point, third point, this is region 1 and region 2, right? So this is a pressure and this one maybe longitudinal force or stress may be indicated as, right? Thank you. So here we can conclude that the maximum pressure will be at entry point, right? This is a center point, there is a exit point, there is a entry point, right? Otherwise we can call it as loading point, center point, unloading point, because this is where it is going to hit the ground. This is center So this is unloading, loading, center point, unloading point. Here it is going to release from the pressure, right? Okay. So at the loading point, we get maximum pressure. So the pressure distribution is not symmetrical here, it is unsymmetrical. This unsymmetrical takes place because of hysteresis losses of viscoelastic material nature. Thank you.